Okay, let's begin. So I have the test. I'll give the test back at the end of class because I don't want you guys reading while I'm up here.
Now we get distracted by anticipation.
Pay attention.
I mean, it's not excusable. It's just.
Do you know your dog is accurate? It's bad. And that's why she wants to.
Yes.
Yeah, I never really look at it. I don't really give people a grade based on how I grade individuals. I grade you.
In general.
I don't grade you based on how everyone else is.
I don't live in a space like that.
Yeah, some people did. Some people did do well. Yes, I had more than a handful got over 100.
Do you know what the class
That's not
Over 100. It's possible. Some people got over 100. So what happens when you get over 100? What I do is I take those extra points and I add it to the next test.
What was the class?
I don't. Anyway, so I'll hand those back at the end, and I'll make some comments. And now, last time we derived a bunch of performance for lines, let's actually put them to good use. So let's start there. Picking right up where we left off.
Oh my god.
So this was actually on a bonus problem on the test, and yeah, a lot of people actually got extra. This is how they got more than 100. Like a lot of people got these questions correct. Find the line through, of course, the equation. I mean, through -1, 2, and 3, 4. Last time I gave you the equations for lines, you know what the equation of a line looks like, you know what the slope would look like, you know all the formulas that would go into them. And so now let's put that to good use. Find the line through that point, that is A, has slope 2, D is horizontal, C is vertical, D is perpendicular to 2x plus 3y equals 7. E parallel to. Find all those lines. So, like I said, a lot of people picked up extra points here. So I asked about 2 equations of lines in the bonus problem, 5 points each. So a lot of people just got 10 extra points for that. So I'm pretty confident that most of you know what's going on here. I think anyone who didn't really get to this is just because they ran out of time. Which, apparently not a lot of people ran out of time. So there were only maybe 2 or 3 people who left a few problems blank, but most people actually attempted everything and attempted most of the bonus problems. So, which means you guys had more than enough time, which that's good. So, let us start 1. How do I find the line through that? First find the slope, which is y2 minus y1 over x2 minus x1. And it doesn't matter who you label which, so let's just call this x1, y1 just because, that x2, y2 just because. And so the slope here is going to be 4 minus 2 over 3 minus a minus 1, which is going to be what? It's a half. So now we use y minus y1 equals n x minus x1. And so we have y minus 2 equals 1/2 x minus plus 1. That's the line.
So if you just left the x like that, did you guys full credit or do you
Yep,
just like?
I gave them full credit.
Oh, you left it like that?
Yep. Some people like writing it in y equals mx plus b form. Unless I specifically ask you for it, I don't really care.
Oh, okay.
But you could go further. This would be 1/2 x. That would be plus a half, plus 2, so that's 5 over 2. So, or this. So if I don't specify, I don't really care what form. So just plug it straight into this and don't do anything. Yep, so that would be 2. A. How do I find the line through that point that has slope 2? So if you're using y equals mx plus b. So you can do the y is 3, the m is 2, the x is minus 2, which means that your b is 7, and so you can say that's y equals minus, the slope was 2, 2x plus 7. Or you can just plug directly into the point slope form. That's going to be y minus 3 equals mx minus 2. Okay. How do we find the horizontal line through this point? Horizontal lines have what form? Horizontal? What's the other? A value equal y, so it's y equals something. So if you're passing through this point, what do you think the y is going to equal to? Y equals 3. Just read it. It's always going to be 3. Right? So that's just the horizontal line that passes through minus 2 comma 3, but it's always going through 3. So once I know one y value, I know all y values, because that's the property of a horizontal line. C. It's going through this point. Negative 2. Yep. So just pick out the x coordinate. D. How would you do if you know it's perpendicular to some other line? Find the slope of this line. So what's the slope of this line? It's 3y equals 7. What you can do is you can solve for y. That's going to be minus 2x plus 7, and then you divide everywhere by 3. So that means the slope is minus 2/3. So here you're going to choose m equals, what do you do for perpendicular? Negative reciprocal. A couple people just made it negative. You have to flip it and make it negative. So it becomes positive 3/2. And then I'm just going to have y minus 3 equals 3/2 x minus a minus 2. And what if it's parallel? Same slope, so E, so we take m equals the negative 2/3, right? Because it's going to be, it's the same line. So then it's y minus 3 equals m x minus a negative 2. Yeah.
Supposed to put it in that form.
No,
Okay.
it's totally optional. Yeah, that's it. Not much more to do on mine. It's very anticlimactic. The entire class built up to that. Last class built up to this. So that's how you should build time equation lines. Now, not only should you be able to find equation of lines, you also need to know how to sketch the equation of lines. So we introduced the Cartesian plane a couple classes ago, and it was useful for actually drawing equations. And that can be very, very useful. So now, let's look at how we want to sketch lines. So, general strategy. General strategies are important. Give you a strategy for something, pay attention, know the strategy. That was one thing I noticed on the test. Well, there were a couple of issues actually with the people that had issues. Is that they never really knew what they were doing. You know, they'd have this equation. They're like, well, let's just multiply by this. Okay, let's move this over there, and they're just doing all this math, but it never really led anywhere. And they'd write something, and then they'd scratch it out, and then they start somewhere else, and then try not that, and they scratch it out. It's like they were just digging themselves into holes and then getting back out because they never really knew where they were going. Know the general strategies. If you're solving a problem, there's a specific thing you need to do in a specific order. There's always going to be that for every problem in this class. You shouldn't be trying to figure out what should happen. Like if I tell you to solve an equation or solve an inequality or sketch something, there's something you should do first, second, third, fourth, and I'm always telling you what that thing is. Pay attention. You have a comment?
No.
Okay, so here's the general strategy. When sketching a line is what you want to do, here is how you're going to do it. 1, you're going to find the intercepts. Okay, so now the intercepts are referring to the x-intercept and the y-intercept. Now, not every line will have both, and we'll deal with the special cases as they come, but in general, the idea is to sketch a line, you only need 2 points, and usually the most convenient points to have are the intercepts, because to actually find them, it's going to actually be very easy. So this is where line touches x-axis. Notice along the x-axis, your y equals 0. So to find the x-intercept, set y equals 0, solve for x. And the y-intercept is where the line touches the y-axis. Along the y-axis, all x-coordinates are 0. So what we're going to do is we're going to set x equals 0 and solve for y. Now most lines, especially the ones that you'd be sketching if they're not horizontal or vertical, they will actually have both of these. So now, 2, you're going to plot these points. 3, draw a line through it. If you're sketching a straight line and you plot more than 2 points, you're wasting time. You only need 2. Let me emphasize that probably. You only need 2 points at most to sketch a line. Now, the exceptions, these are vertical and horizontal lines. This one, but these, they are the exception in a way that's actually kind of easier. You only need 1 point. you'll need one point to be able to sketch a vertical line. You just need the x coordinate. So if the point is h comma k, then x equals h is going to be the equation of your line. Very similarly here, you only need one. If the point is h comma k, then y equals k is going to be the line. And so this one is going to be a vertical line passing through the point h comma k, and this one is going to be a horizontal line passing through the point h comma k. So sketching those shouldn't be an issue. Now for anything that's not vertical or horizontal, that's how you're going to do it. Find the x and y intercept, plot them on the graph, plot them on the axes, and draw a straight line through those 2 points. So sketching a line is a 5-second job. It shouldn't be taking long. Maybe 10 seconds. Right. So that's all you need to sketch a line. Find 2 points. Usually the most convenient points are going to be the x and y intercept. In the event that you can't find both, it's probably because it's horizontal or vertical. Let's look at some examples. This one, a 2x plus 3y equals 6. Now here's the nice thing about this. Some people might have the urge to, oh, maybe I have to write it to look like y equals mx plus b before I can sketch it. No, you don't. You don't need to have it in a certain form. You are going to do the x-intercept, and this sometimes you don't even have to write it down. Okay? How do you find the x-intercept? Cover that up. Pretend y is 0. Divide by 2. How do you find the y-intercept? Cover that up. Pretend the x is 0. Divide by 3. So what that means is on the x-axis, you're going to hit 3. And on the y-axis, you are going to hit 2. So there are 2 points here. And you just draw the line through. That's what that line is going to look like. So cover up the y, solve for the x, that's 3, plot it on the picture. Cover up the x, solve for the y, that's 2, plot it on the picture. That's 2 points, you don't need any more. Draw a straight line to the best of your ability as a human being to draw. Okay. That's it. So we're going to draw that, x, y, what's the first thing? Well, plug in x equals 0, your y is going to be 3. Plug in y equals 0, your y is going to be, now you have to move the 3 over, you get a minus 3, multiply by a minus 2, you get 6.
So even on the y-intercept, I just put in x at 0 and then just put in 3?
Yep. That's always how you're going to do it. And this goes beyond just lines, by the way. To find the x and y intercept, in general, that's always how you do it. Plug in x equals 0 and solve for the y, that will give you the y intercept. Plug in the y equals 0, solve for the x, that will give you the x intercept. And it might be in y equals mx plus b form, it might not be, it does not matter. Just do that, cover up one, solve for the other guy, plot it on the axis. Now, when you have this guy, C, y equals 1, one thing you're going to notice is that's horizontal. You only need 1 point. It might as well be the one on the axis, why not? Y equals 1, so it definitely passes through the point where there's a 1, and it's horizontal. That's the picture. X equals minus 3, so draw the axes. You'll need 1 point because this is a vertical line. Might as well be the one on the axis, so just go and find x equals minus 3. Write it off to the side a little bit. And then, yeah, draw a vertical line through that. That's it, that's sketching lines. You need to know how to do that quickly. By the end of Calc 1, what's going to happen is you're going to be sketching a bunch of graphs all at once on the same axis and trying to figure out what region is bounded in between them. So you need to be able to do that quickly to be able to do, finish up the rest of your calculations. So sketching lines, parabolas, and polynomials in general, as well as trig functions and logs and exponentials, is going to be something that they will expect you to be able to do very quickly, because the problem starts after you do the sketch. Right? The problem is not going to be to do the sketch. So if you're taking a long time to sketch a line, it's a bad sign. You need to figure it out. But that's basically something else to do. And since we're here, your textbook talks about this in a later section, but let's talk about graphing in general. At least for polynomials. So we figured out how to graph lines, check. The next category of things I want you to know how to draw are parabolas. And then I'm going to want you to know how to draw general polynomials. Also trig functions, exponentials, and log functions, but I have to tell you what those guys are before you know how to graph them. So for now, we do have enough knowledge to be able to sketch these, so let's actually learn about those and sketch them. Now, y equals ax squared plus bx plus c, where your a is not 0, is called a quadratic function. its graph is called a parabola. In practice, quadratic and parabola are used interchangeably, but they're technically not the same thing. But they're technically not the same thing. Quadratic is the name of the equation, parabola is the name of the picture of the equation. But if you call this, oh, that's a quadratic, or hey, that's the equation of a parabola, no one's gonna like bat an eye at it. So we use these words interchangeably, but technically one refers to the picture, the other refers to the equation. Now, here are some key facts on sketching the parabola. One, note the sign of A in the original equation. Sometimes people might modify the equation to be able to solve for the intercepts, which we're going to be able to do. But just know that if you actually change anything, or you divide through by like a negative number or something like that, the sign that you should take note of was the one in the original equation. And I want to note the sign of A. Because this indicates the shape. So a parabola has only two possible shapes, this kind of parabola. If your A is a positive number, the shape will be this, like a smiley face. While if your A value is a negative number, it would be an inverted parabola, we call it. It's going to shape like that. So just by you seeing what that number in front of the x squared is, automatically tells you what shape it's going to be. Now your goal is to be able to draw this shape through convenient points. How do we find the convenient points? 2. Common ones. 1, the x and y intercept, once again, is going to be a very common set of points. Now, a parabola will always have a y-intercept. This is 0, c for a parabola. Always. So parabolas will always have a y-intercept. They might not have an x-intercept though. So that leads us to another convenient point that will be convenient. If no x-intercept, plot what's called the vertex. Now the vertex, this is the highest or lowest point. So if your graph is upside down, the vertex is going to be the point that's right at the pinnacle of here. Or if your graph is a regular parabola like that, the vertex is going to be the lowest point here. And it turns out you can prove this using completing the square on this guy. But some of you guys probably already remember it. How do you figure out what the vertex is? There's a condition in terms of the x-coordinate that should be people usually remember. It's minus b over 2a. that will always be the x-coordinate for the vertex of a parabola, of a quadratic that has that equation that I just gave you. And then you can plug in to find the corresponding y. Plug into original. Again, make sure you're using the original equation, because throughout the problem solving process or the sketching process, you might manipulate the equation, but make sure that anytime you're figuring out what way it's supposed to open up or you're finding coordinates, use the original equation. Plug into original equation to find y. So first thing you're going to note the sign. You're going to notice, is it going to open up or is it going to open down? The next thing you're going to do is you're going to find convenient points. Now usually for a parabola, there are going to be 3 points. Sometimes you can get away with 2, but for a parabola, you need at most 3 points. You can often get away with less than that. But in my time, I've seen many things, like people sketching parabolas with like 10 coordinates. Like, how long did it take you to plug in all those x values and figure out all those y values and then plot them on a picture and then connect them all? Like, why? You only need 3. And that's, again, sometimes that's even more than enough. The 3, of course, will be, usually a parabola will have 2 x-intercepts and 1 y-intercept. So it'll at least have a y-intercept, and if it has no x-intercepts, what you can do is you can plot the vertex and you can actually figure out what it's going to look like with those 2. Otherwise, you can have 2 x-intercepts and 1 y-intercept, and that's more than enough. That's plenty. Don't go beyond 3. You're wasting time. You're now just wasting time plugging into stuff and evaluating when you don't have to. So first, figure out what the shape should be. Is it opening up or down? Second, find convenient points. You need 3 maximum. X and y intercepts are usually the most convenient ones. If the x intercepts aren't helping you out, find the vertex. To find the vertex, that's going to be the x value to find the vertex. If you want to find the y coordinates, you plug that x value back into the original equation, solve for the y. Now, the third step, fit it here, sketch the shape in step 1 through the points in step 2. And you will now have the graph of the graph. Give some time to write that down, and then we'll jump into some examples. Okay, so first step, what do you do? Find the shape. 1. Notice that your A is -2, which means the shape is going to be upside down. So at the end of the day, I need to be drawing that shape. Don't forget that. Okay. Now, second thing you want to do. Points. How about intercepts? Let's find the x-intercept. How do you find the x-intercept? Set y equals 0. Now we have that kind of equation, but we know how to solve that kind of equation. At least we should. What do we do? You can factor out a -2.
Wait, you change the sign. And A is negative 10.
Can we get?
Yeah.
Oh, the 10 is negative.
Oh, yes. Which means this is negative, which means that is positive. Now what? Huh?
Factor.
Yeah, you factor. That's how we solve equations. That's the strategy for solving anything that's not a linear equation. Bring everything to one side so the other side is 0, and factor. There are a couple people who didn't remember that that's how we solve equations. I had a 4 over here, and then they started setting things equal to the 4. Like, no, it has to be a 0. It's called the 0 factor property for a reason. What is this factor? -5, -1. So your x would be 5, or your x equals 1. So you already have 2 points. Those are the 2 things that on the x-intercept. Y-intercept means you plug in x equals 0, 0, 0. That means y equals -10. You now have 3 points. Nothing else to do now but sketch. So we are going to have, let's say, boom, boom. Sometimes what I like to do is I actually sketch it before writing in the points. Because what happens sometimes is like people will go like, okay, this is a 1 and this is a 5, and I'm gonna make down here. Worse, they might do the notches, like which isn't necessary at all. Put the -10 down here, and then they go like, oh, and they try to bend the curve to fit the things that they put in the first place. Like sometimes I kind of prefer to actually draw the curve first and then write in the points. So if I know it's going to hit negative on the y, what I'm going to do is first draw something. So now it looks very smooth, very nice. And then afterwards, that's a -10, this is a 1, that's a 5. It looks nicer.
So, can we still do the notches if we can?
I would say no. They're a waste of time. I don't know where people got this notches idea. Because even when I was a little Jhevon and I was learning, I was never encouraged to write the notches. I don't know why people do that. Oh, so it can be more precise. You're a human being drawing by hand. It's never going to be precise. You're attempting to do something that's impossible. You're not a computer. Like, even your notches, they're not going to be the same distance apart. You do realize this, right? Oh, it's more precise. No, it's not. As long as it's everything is relative. As long as things that are bigger are to the right on the horizontal line and down on the vertical, that's kind of what matters. Make sure it goes to the right points.
So I have a question. So if
Yeah.
you want to find the vertex of A, we should just do -12 over 2 times -2. You get?
Yeah, -b divided by 2 times this.
Okay.
But you don't have to do that
yeah,
for this.
you have to
But
do it.
technically, yes, if you wanted to find that point,
Right.
you'd have x equals -b over 2a, that would be -12 over 2 times -2, that would actually be 3.
Yeah.
which, by the way, if a parabola, I'm always afraid to say this because people always mix this up. For parabolas only, it does not work with anything else, no other graph. For parabolas only, if there are two x-intercepts, the vertex is going to be exactly in the middle. It does not work in any other graph, okay? Parabolas only. Someone's going to draw a cubic, and I know they're going to take, they're going to have a graph that looks like this, and they're like, this is a 1 and that's a 5. Oh, this must be at a 3. No, no, parabolas only. Okay. To find maximum and minimum points in general is, I won't say hard, but you need calculus to be able to do that.
So now we don't need the formula.
Come here.
So that we don't need the formula.
Which formula?
The vertex formula.
We didn't need it
In the
here.
middle.
We didn't need it here. We could need it. It depends. Because sometimes your parabola won't actually touch the x-axis. Right? Like that. How are you going to find that point now? Right? So, in this case, we didn't need it, but we could need it. For sketching, we don't really need it if we have both x-intercepts and the y-intercept. There's no need. The vertex would be for a different reason. Yeah, so that would be the first graph, and that's how you do the problem. Notice the sign in the of the x squared term in the first original equation. That's going to tell you if it should be opening up or down, smiley face or frowny face. Find the intercepts. Normally you're going to end up with something here where you're going to have to factor to solve for the x's. If it exists at all, it's possible that no solution exists here. And if there's no solution here, that's when I would find the vertex. That's when you would use it. And you find the y-intercept by plugging all the x values here. So that's going to be the picture. Questions? So step 1, notice that your A is 1, which is positive. So this one actually opens like that. Step 2, let's actually try to find the intercepts. So we can start with the x-intercept. This means 0 is equal to x squared minus 2x plus 2. How do I solve that? Can you factor? Pause. It doesn't factor, right? What do? Quadratic formula. X equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a, which here is 1. What happens here? There's a negative under the radical. What does that mean? No x-intercepts. So now we're in a situation where we don't have these points to help us out. The y-intercept is definitely going to be there though. Just plug in both x is equal to 0, y equals 2. So far all I know about this graph is that it passes through y equals 2. Now there are some guesses that you can make here. Y equals 2 technically, depending on the situation, might be enough. It might be good enough for the sketch that you want. But yeah, we can just put here 2, and I know it's opening like that. But the question is, there are actually a couple options here. It could look like this, right? But it never touches the x-axis. But it could also look like this, right? So now there's like we don't really know where it should be opening. So this is where the vertex comes in handy. Since no x-intercept, you don't have to write this down because it's just a parenthetical statement. Since no x-intercept, find vertex. So now we know that x equals minus b over 2a. This is going to be 2 over 2 times 1. So that's 1. So I know it occurs when x equals 1. So actually the picture that I drew on the right was the actual better picture. We could find y here, probably not necessarily. Could find y. How would I find the y? Well, I would go to the original and I would plug in the 1. And you get y equals 1 as well. So 1 comma 1 is the vertex. So this guy is going to look like that's going to be the curve. I know that the y-intercept is 2, and I know that this lowest point is going to be 1 comma 1. So that's going to be above where the x is 1 and across the y is 1. So that's going to be the graph. So here I could figure out the graph with 2 points. When it comes to sketching, x and y-intercepts, they're usually a safe bet. If the x-intercept messes up, the y-intercept will never mess up. Every parabola will have a y-intercept, because it's just going to be c. But if the x-intercept messes up, just use the vertex as the extra point, and that'll help you figure out how it needs to be drawn. So we're going to draw this smiley shape through those 2 points, knowing that this point is going to be the lowest point. Questions? Yeah.
So you say that that only has 2 points, right? Just to clarify.
We only need 2 points to sketch it, yes. So usually the x and y-intercept give us all the points we need, but in this case it didn't, so we just use the vertex as an extra point. Let us do the other. Yes.
I don't know what to find first there.
Doesn't matter. Because you're going to find them all in one step, and then you're going to draw them in the next step. So it actually doesn't matter who you do first over here, because you're going to end up plotting both of them at the same time over there anyway. So the order there doesn't matter. Same thing. Here you're going to notice that your A is 1, which is positive, so that's also a smiley face. Then you're going to try to find the intercepts. So for x-intercept, 0 is equal to x squared plus 6x plus 5. That factors, it looks like. X plus 1, x plus 5. And so x equals minus 1, x equals minus 5. Are the x-intercepts, y-intercept? It's going to be y equals 5. That's 3 points, more than enough. So both of the x-intercepts are negative, and the y-intercept is positive, so the graph is going to be to the left side of the y-intercept. So I'm just going to sketch a parabola. Put these guys in afterwards. Minus 5 here, minus 1 here, positive 5 here. Huh?
You have the -1 and the -5 from the
Yeah, by setting each equal to 0. X plus 1 equals 0, x plus 5 equals 0, 0 factor property. And Now for this one, you can just realize that if we were to multiply it out, inside here I get an x squared plus blah blah blah, and then this 2 is going to multiply that out. So the a here is 2. In fact, it's greater than 0, which means it should look like this. And in fact, if a quadratic is written as y equals ax minus h squared plus k. Sometimes you can have a quadratic written in that form. Then this is the a from the original form. Same a from other form. What's nice about this form is that it also tells you the vertex right away. It turns out that the vertex, whenever a quadratic is written in this form, the vertex is going to be equal to h comma k. So in other words, by looking at this equation as written, I know the vertex is at 1 comma 4. So that's just a side note there. So this is like you take a quadratic equation and you completed the square. And you can notice that you could have done the same thing with this. If you completed the square here, that would look like x minus 1 all squared plus 1. And we found that the vertex was 1 comma 1. So here we can know 2 intercepts. Combine the y-intercept first. So this means, what's the y-intercept here? It's not 4. It's a trick. Yeah, it's always set x equals 0, solve for y. So it's 0 minus 1 squared plus 4. So that's actually 6. Okay. Now the vertex is 1, 4. So when in this form, I probably wouldn't find the x-intercept because that's actually extra calculations and it will take a lot longer. This I can just look at the equation and know what that is. So that's should be enough actually to sketch this graph.
What's that blue thing say? Same a something?
Same a from the other form.
Oh.
That means the original one era y equals ax squared plus bx plus c. Right. This you can think of the coefficient here as the same. It's the same guy.
Oh.
My vertex is going to be 1 comma 4. And my y-intercept is going to be 6. So this actually opens up like that. This is at 1 comma 4, and that is at 6. And you would have noticed if you had tried to find the x-intercept here, you would get something that you couldn't solve in the real numbers. So that's that graph. Now we'll look at graphing more general things later, but I think for now we can stop because we should be getting done in 10 minutes. So sketching lines and problems, we know how to do that now. Okay, so I'm going to give the tests back. Here's something to note when you're looking over it, making sure that, so of course, go look over the test, make sure that everything is okay, make sure that you understand where your grade is coming from, that sort of thing. But one thing to note about the test, and the solutions are already up online also, by the way. Each problem, I made it equally weighted. So each problem, there were 15 problems, so that doesn't divide evenly to 100, as we all know now, we're on pre-calc big kids. So it's out of actually 20 over 3. So pretty much I think of each problem as a 20-point problem, and I just divide up by 3 at the end. So I essentially like graded your exam out of 300, divided the answer by 3, and then I rounded up. So I always round it up, even if it shouldn't. So each problem is worth 20 over 3. So which is like 6.67, something like that. So like 6 points and change per problem. So you're gonna see a weird grading thing going on. That's what that is. What is all these fractions you want writing all over? I made a note of what you got from each problem, and I added it and put it in the top corner of the page. So just so you know. And it's back. You can leave afterwards. If you, like I said, take it home, read it over. You can see me, I guess, starting tomorrow if you have any concerns or questions or issues, and we can deal with it.